All right, in today's lesson, we are going to remind ourselves of transformations of parent functions. We're going to start with shifting, reflecting, and stretching graphs. Now, these are 6 parent functions that I'm hoping that you've seen before. So let's just remind ourselves what they were. Linear is y equals x, and that's your basic function you learned about in Algebra 1. It's just a straight line that goes through the origin with a positive slope. Then you learned about the quadratic function in Algebra 1 also. This one is y equals x squared. Maybe you learned about the absolute value. It makes a v. I know you learned it in Algebra 2. Looks like this. Y equals the absolute value of x in those bars. The cubic function looks like a snake going through the origin. Y equals x cubed. So you're going to need to know these basic shapes, by the way. Square root function sits at the origin. It looks like somebody standing over the diving board. And that's just y equals the square root of x. And then the reciprocal function. I don't know if you learned it or not. You may have learned it as the rational function. It means the same thing. It's just y equals 1 over x. And this one looks like this. Looks like 2 L's. They don't cross the axes. They're just kind of opposite L's. And then some vocabulary about the transformations we're going to do. Okay, there's 2 kinds of transformations. There's rigid and then there's non-rigid. So rigid transformation means it maintains the shape. Doesn't mess with the parent function shape. So what is that? Well, that's like a horizontal shift, a left and right. We move it left and right. A vertical shift. That would mean up and down. Or we could do a reflection over the x-axis or y-axis. The shape stays the same, it just flips across the axis. Now, non-rigid will distort the shape, and we'll do some of these, so don't worry. That would be a horizontal stretch and shrink. And that's where you think about like an accordion. Okay, stretching and shrinking, a vertical stretch and shrink. Okay, that's going up and down. And we're going to deal with the non-rigids tomorrow. Today we're going to focus on the mostly the rigid transformations, all right? So let's flip to the next page. Vertical and horizontal shifts on y equals f of x. Now, just for example's sake, I'm going to use y equals x, my linear function, the basic function, but just know that any of these could be happening with any of those parent functions. So if a vertical shift of c units upward, well, let's say I had y equals x plus 4. That would mean it's moving up 4 units. This is the c. C stands for constant. It's just a number with no variable. A vertical shift downward, what would that be? Well, that would be like y equals x minus 4. The minus means it's going to go down 4. To the right and to the left. Now, this goes opposite of what you would think. So this is going to, let's say we used x minus 2 plus 4. So what is going on here? Well, it's still an up 4. Now, this minus 2 goes opposite logic because it's in the parentheses. It's only happening to the x value. So what you think would be going left, because it's negative, is actually going to go right 2. So this one has 2 transformations. What if it wanted to go to left? Well, we would just change it to x plus 2. So the plus goes left 2, all right? And that plus 4 is still up 4. That didn't change. Reflections on the x-axis, reflections on the y-axis. Now, this can be a little tricky, the way it looks, but let's just use y equals negative x. Y equals negative x means that negative's on the outside, right? And what does that mean? Well, that means my function that maybe was originally a quadratic like this is reflecting and going to go across the x-axis there that way. Now, if it's a reflection on the y-axis, these are not very common, but it would look like this. That negative would be inside parentheses. Now, the weird thing about a reflection on the y-axis is, let's start with that quadratic again, it means I'm flipping this way. But do you see that if I flipped this way, it's still going to look the same? So it visually remains the same when you do a horizontal or a reflection on the y-axis. So make yourself a little note. Visually looks like the original in most cases, okay? Visually looks like the original when you do that. Now, let's look at some examples here. Sketch the graph of each function on the same graph and describe the transformation as rigid or non-rigid. All right, so if the original function is x squared, it's the quadratic function, okay, nothing, this is where I'm starting. So my quadratic function, I'm going to do that in blue, looks like that. Now, I'm changing g of x on your notes because we haven't covered vertical stretches yet, but this one I'm going to change g of x to be x squared minus 4. So it's taking my quadratic and moving it down 4. And then I describe, is that rigid or non-rigid? Well, it's just moving it down 4 units. So it's just doing this and maintaining the shape. So this would be a rigid transformation. All right, then let's look at the next one. I've got a couple things going on here. That plus 2 would mean I'm going to move it left 2. The 1 means I'm going to go up 1. So my vertex, my origin, is going to move left 2, up 1, but the shape is not getting changed at all, okay? So since the shape is maintaining, this would be a rigid transformation. All right, got one more example for us today. We're going to start with this one, the parent function of the square root function. So I'm going to graph that. Remember, it looks like somebody standing up over the diving board. Now, I'm not going to get picky on points, but I am going to be making sure your shapes make sense, okay? Now let's look at this. G of x is taking that original function, and what is the plus 2 doing? It's moving it up 2. So I'm going to change colors. I'm going to move up 2. But the shape is maintaining, which means it's going to be a rigid transformation. Did not change the shape. Now look at H. H is a little different. We got a couple things going on. You notice the negative back here? That's a vertical reflection. So it's going to go upside down. And the minus 4 means it's going to move right 4 units. So I'm going to go over 4, 1, 2, 3, 4. And instead of going up to the right, I'm going to go down to the right. That is the vertical reflection. Now notice the shape is the same, it just went upside down. So this is still considered a rigid transformation. All right, hopefully that makes some sense to you. And sorry for editing your notes just slightly, but I want to do one thing at a time. All right, we'll talk more about this when we get to class and do the in-class portion. Good luck.